In this video, I'm going over our lesson about now introducing the graphs of absolute value. So after that Desmos activity that we do here, then notice how, so we have this V shape now for our absolute value. So like here's the parent function, just good old absolute value of X here that's been graphed. Now keep in mind, this is the general form because we could transform it just like when we had our radical equation. Like if you think about it, right? Whenever we had the square root of, let's say, x plus 3, then minus 2. Well, the 3 meant that we went 3 to the left, and then here we went 2 down. It's the same thing with absolute value. This h here inside of our absolute value bars represents our left and right. And just like the radical, we're going to go opposite. Then here that k value outside that's being added or subtracted, just like the radical, is going to represent the up and down, our vertical shift. Then here now we could have positive or negative. So again, if it's negative, then that's again going to represent the reflection, but now over the x-axis, just like before. Now, A here, though, is going to now, we're going to start looking at the slope. So it's still how we called it, the vertical. So it could be a vertical stretch or shrink. But we're now going to be looking at the slope or that rate of change. So remember, you could see it as either or. So with the slope, so like notice, for example, here is just up 1. So here, so notice the slope is just 1. Up 1, right 1. So notice here how we have that slope of 1. And then notice how here, slope of 1, just that negative. Here, we're going to make sure to look at that slope both directions. That's going to be your slope here. So like, for example, 1a, just to kind of get an idea of what we think this would be, but we'll graph this first so you can see the visual. So graphing 2 times the absolute value of x plus 1. So here, notice we moved up 1 here, so we're at 0, 1. Then also look at the slope. I'm going up 2, right 1, up 2, right 1. And also notice we stayed at 0. We didn't go left or right. We just went up 1. So notice how that matches our equation. We moved vertically up 1 unit, so that was our vertical shift. And then we also have our slope, which is here at 2, so that rate of change. And you could also want to say that this is a vertical stretch because it's greater than 1. So here we went up 1, and then up 2, right 1, up 2, right 1. And then same thing. Here, notice how they're going to match. That means the vertex is the highest or lowest point, which is right here at 0, 1. So keep that in mind too when looking at that vertex. So like here, before we do example 1b, how about going and pause the video and see if maybe you think what the transformations are before we take a look at the graph. So let's see what you thought. I see a negative on the outside, so I've got that reflection over the x-axis, which now means it's going to be facing downward, all right? Here, inside is the plus 3, so that's a horizontal shift, 3 to the left because we're going opposite, and then minus 2 on the outside, so that's your vertical, and we're shifting 2 down. So let's check that. So here we went, here's our vertex. We went 3 to the left and 2 down. There we go. And notice how now, from the reflection, now it's facing downward. So all of this represents. So here our vertex was at -3, -2. Also, forgot to mention the slope. Well, notice here, we're just going 1. So over 1, right 1, over 1. So our slope also did not change here, which there was no value. So our vertex is at -3. Notice how here, with the -3, -2, that our X is representing our left 3 and down 2. So here, and again, the slope was just 1, but again, sorry about that, going now facing downward here. Go ahead and pause the video now and try the U-try on your own. And here we go. So the transformations, well, I see a negative on the outside. So again, we have a reflection over the x-axis. So it's going to be facing downward. We shift 4, but now to the right. So that's your horizontal shift to the right. And then 5 units down. That is your vertical shift. So if I'm going 4 to the right, then that means I have positive. And so again, here we've got positive 4 and negative 5 as your vertex. So now we're going to write the equation, but make sure to check the slope. So like here, for example, we're shifting 3 to the left and 3 down because this is your vertex here. So notice the vertex. Oh, I'm sorry. That's a typo about that. Sorry, my fault, y'all. So that should be 2 units to the left, 3 units down because we go left 2, which makes this negative 2, and down 3, so negative 3. So here, if I'm going left 2, down 3, that means we have x plus 2, right, to show the 2 to the left and 3 down, so minus 3. Now notice we are still facing upward, so we don't need the negative. But now let's check the slope. I do notice it's not our usual. See how it kind of got shrunk here? Because here our slope is 1, 1, 2. So notice how our slope is 1/2. So here the equation is 1/2 times x plus 2, the absolute value of x plus 2 minus 3. So keep in mind the slope. So now here in the next example, we're shifting 2 units to the right, 3 units up. So notice again how that matches, and our vertex here is at 2, 3. So 2, right 2 and up 3. And we're also facing downward now, which shows that reflection. So we do need negative on the outside, then x minus 2, right? Not if we're going to the right 2, I'm going to put minus 2, then up 3, so plus 3. But then let's check the slope. So this is a negative now from here to here. So we have our rise, right? So remember, slope is rise over run. So here I've got up 2 over 1. So 2 over 1, 2 over 1. So this is negative 2. So that's why you have negative 2 here times x minus absolute value of x minus 2 plus 3. So go ahead and pause the video now and try these 2 U-tries on your own. And here we go. So here we're shifting right 1. So if I'm shifting right 1 and my vertex is here is at 0, 1, and we're still facing upward. So my equation, if we're shifting right 1, then that's minus 1 here to show that shift. So the absolute value of x minus 1. Staying positive, but checking for slope. So again, notice here, we're going 1, 2, 3. So up 3, right 1. 1, 2, 3, right 1. So the slope is 3. Notice how it got stretched. So that's your vertical stretch here. So now here we went 4 to the left, up 1. So again, matching your vertex. So if I'm going 4 to the left, I'm at x plus 4. Then up 1, so plus 1. Now notice we did have that reflection because now it's facing downward. So I do that negative here on the outside of our absolute value. Then checking slope, we're 1, 1. 1, 1. So nothing was changed, so it's just negative absolute value of x plus 4, then plus 1. Go ahead and pause the video now and try these 2 U-tries on your own. And here we go. So which equation represents a shift 2 units right? So that needs to be on the inside of our absolute value and reflected over the x-axis. So I do need that negative on the outside here. So because it's 2 units to the right, well, this is a vertical stretch, and this is 2 units up. So if I'm going 2 to the right, remember, this is the opposite, right? Because when it's on the inside. So that's why here you should have gotten C. Then here we're taking the absolute value parent function and transforming. Well, notice we have the 1/3, so that's our vertical shrink because now our slope is less than 1. And 5 is here, minus 5 on the outside, which represents your up and down, so 5 units down. So I know that it's 5 units down, so I'm now down to B or D. Well, this is a vertical shrink because it's less than 1, so that's why you should have gotten B.